The main quality of a modern greenhouse is its ability to provide maximum yield, be cost-effective, maintaining stable high productivity at any time of the year. The main costs in greenhouse complexes are associated with energy consumption and can reach more than 40%. 30 to 40 years ago, the greenhouses were made of wood of 2.5-meter height, with single glazing and without screen systems. Nobody worried about energy savings at those times. At the beginning of the century, greenhouse construction began to develop at an accelerated pace. Screen systems with high percentage of energy savings started to be used. Gables received double glazing, and roof joints received rubber seals. All this allowed to create uniform microclimate, increase energy savings, and reduce gas consumption. At the same time, a new problem appeared: high humidity inside the greenhouse, which causes such diseases as fungi and mildew, leads to crop loss and overcosts for disease fighting and greenhouse maintaining. Heat energy in the greenhouse is generated from a simulation system, heating system, and from solar radiation, and only 4% of the energy is transformed into crop and fruits. The remaining 96% are distributed inside the greenhouse. That leads to evaporation from plants and formation of vapor, thus increasing the humidity. Attempts to get rid of high humidity by windows opening and screens closing lead to a bad microclimate, and as a result to uneven growth and plant diseases. The unique air and energy system solves these problems. The system regulates the humidity in the greenhouse in such a way that energy loss has become the minimum possible, including when the outside temperature strongly drops. The system uses two fans: an inlet fan to capture air from the outside to the greenhouse, and an outlet fan to draw the air from the greenhouse. Air flows in the unit pass separately from each other through the recovery section without mixing. Recirculation fans with sleeves are installed under the growing gutters, which ensure constant air circulation between the plants. The fans move the air of required temperature and humidity from the air and energy units to the under part of the growing gutters. The air moves slowly in the greenhouse, does not overheat the plants, and creates ideal conditions for their active growth. Let's look at an example of humidity balance when using the air and energy system. The outside air temperature is 0 degrees Celsius, with a relative humidity of 95% and absolute humidity of 3.58 grams per kilogram. It enters the heat exchanger from the outside. From the greenhouse to the heat exchanger, the air is supplied with a temperature of 20 degrees, with relative humidity of 85% and absolute humidity of 12.42 grams per kilogram. The incoming air from the outside, passing through the plates of the heat exchanger, is heated by the energy of warm air from the greenhouse without mixing with it. By doing so, the absolute humidity does not change, and the relative humidity decreases from 95% to 26%. The warm air from the greenhouse, giving its energy to the air from the outside, is being cooled from 20 degrees Celsius to 11 degrees Celsius. During this process, condensation occurs, and every kilogram of air displaces 8.84 grams of water from the greenhouse. 4.3 grams are converted to condensate, which exits from the unit to the outside, and 4.62 grams go into the vapor state and also go outside. How the system works: warm, humid air goes up through the plants to the greenhouse top, where its temperature rises and the humidity increases. Further, the air goes along the side walls to the end gables of the greenhouse, and through a separate guiding, it enters a special heat exchanger. Warm, humid air from the greenhouse passes through thin plates inside the heat exchanger and gives its energy to cold, dry air, thereby heating it, and excess moisture is removed outside. The efficiency of the heat exchanger in the air and energy system reaches 95%, because cold air from the outside is almost completely heated by the energy of warm air from the greenhouse. From the heat exchanger, the air with the required humidity and temperature enters back to the greenhouse and is distributed by the sleeves, which are suspended from the growing gutters throughout the entire area of the greenhouse. For cold regions, installing of sandwich panels around the perimeter of the greenhouse is recommended. This way, Air and Energy provides complete control over humidity, almost 2 times reduces gas consumption, and increases productivity up to 10%. The system allows to reduce the use of means for plant protection, reduces the need for additional CO2 production from boilers, and also reuses condensate water. Humidity control and the absence of temperature differences ensures a constant uniform climate in the greenhouse with closed windows and screens. In these ideal conditions, plants develop evenly, grow quickly, and do not get fungi diseases. Air and Energy system can work with all modern climate computers. Let's look at the example of climate computer operation. On the greenhouse roof, there is a meteo station installed that shows the outside air temperature is minus 3.2 degrees Celsius. The outside air goes into the climate unit. Its relative humidity is 98%. The absolute humidity is 4.8 grams of water per 1 cubic meter of air. After passing through the heat exchanger, the air, heated to 16.9 degrees Celsius, enters the greenhouse. In this case, energy efficiency is 97%. Relative humidity of the air reduces to 33%. In this state, the air is mixed with a certain amount of recirculated air and is blown through the air sleeve. At the end of the air sleeve row, the temperature rises to 17.5 degrees Celsius. Coming out of the air sleeve, the air rises along the plants up the greenhouse. The measuring sensor between plants records a temperature of 16.3 degrees Celsius. Relative humidity is 84%. Absolute humidity is 11.6 grams of water per 1 cubic meter of air, 9.7 grams per kilogram. Humidity between the plants can be higher than in the greenhouse itself, where a relative humidity of 84% is considered very high, because there is constant air movement that prevents diseases such as gray rot and powdery mildew. The measuring sensor above the plants records a temperature of 17.5 degrees Celsius. Relative humidity is 78%. The absolute humidity is 11.6 grams of water per 1 cubic meter of air, 9.7 grams per kilogram. This value is the same as the humidity value in the area between the plants. In this case, the relative humidity is lower due to a higher temperature. Air goes down the walls to the Air and Energy unit with heat exchanger. The air temperature before entering the heat exchanger is 17.5 degrees Celsius. The temperature of the air leaving the heat exchanger is 6.8 degrees Celsius. The amount of moisture that leaves the greenhouse, on the one hand, is in saturated outgoing air, water vapor, and on the other hand, is in liquid water that leaves the unit and is thrown out. For more than 10 years, Air and Energy system has shown its high efficiency in leading European greenhouse complexes with a total area of over 250 hectares. The unique Air and Energy system is an optimal solution for high yields at minimal cost.